Friends, before any laboratory test, before DGA, TAN, IFT, or BDV, the oil already tells its story, if you know how to look at it. Oil appearance and color is not a cosmetic check. It is the first health indicator. Dark oil, cloudy oil, hazy oil, or particles are never random. They indicate oxidation, contamination, moisture, sludge formation, or insulation aging. Many engineers ignore this step and jump straight to reports. Senior engineers never do. In today's Electroverse episode, we decode oil appearance and color. What clear oil really means. Why color darkens with aging. Difference between turbidity, haze, and particles. IEC oil color scale and interpretation. When oil appearance alone demands action. And how visual inspection prevents serious failures. Stay till the end, because the eye is the first diagnostic instrument.
When you're dealing with power transformers, you probably run dozens of complex tests. Dissolved gas analysis, power factor measurements, breakdown voltage tests. All sophisticated, all important. But here's something that might surprise you. Sometimes the most basic test tells you the most critical information. We're talking about oil appearance and color. And today, we'll explore why this simple visual inspection governed by ASTM D1500 is often your first and most reliable warning system. Let me start with a fundamental truth that every experienced engineer knows. Oil tells its story the moment you look at it. While your lab instruments are busy analyzing molecular structures and electrical properties, your eyes are doing something equally valuable. They're giving you an immediate health check of your transformer's blood life. According to IEC 6422, transformer oil should always appear clear and transparent. That's the standard. Anything else means contamination or degradation. Think about it this way. When you draw a sample and hold it up to the light, you're essentially looking at the cumulative effect of everything that's happened inside your transformer. Heat cycles, electrical stress, moisture ingress, oxidation, it all shows up in how that oil looks. Now let's break down what you're actually seeing. Good oil appearance means the oil is bright, clear, and free from any haze, suspended particles, or sludge formation. It should look almost like water in terms of clarity. When you see this, you know your transformer is operating in a healthy environment. The insulation system is intact, moisture levels are controlled, and chemical degradation hasn't progressed significantly. But what happens when things go wrong? Cloudy or hazy oil means water is already affecting dielectric performance. This isn't just a cosmetic issue. Moisture contamination reduces breakdown voltage, increases power factor, and accelerates the aging of both oil and paper insulation. When you see that telltale cloudiness, you're looking at a transformer that's already compromised. Dark or murky oil means chemical aging has progressed. This is where oxidation has taken hold, creating acids and sludge precursors that will eventually destroy your transformer's insulation system. The darker the oil, the more advanced this process has become. This brings us to the ASTM D1500 color standard. This test assigns a numerical value to oil color, and it's beautifully simple in its logic. Lower number equals cleaner oil. Higher number equals aged oil. The scale typically runs from 0.5 to 8.0, with higher numbers indicating darker, more degraded oil. Here's how experienced engineers interpret these numbers. Color less than 1.5 indicates new or healthy oil. This is what you want to see. Your transformer is operating well, and the oil is doing its job effectively. Color between 1.5 and 3.0 indicates aging oil that needs close monitoring. You're in the caution zone here. The oil is still functional, but degradation has begun. This is when you start planning your maintenance strategy and perhaps consider more frequent testing. Color greater than 3.0 indicates severely aged oil with high sludge risk. This is your red flag. At this point, you're looking at oil that's approaching the end of its useful life. The risk of sludge formation is high, and you need to take immediate action to prevent catastrophic failure.
But here's where it gets really interesting. The color change isn't just about aesthetics. It's a direct result of chemical processes happening inside your transformer. Oxidation creates acids and polar compounds that darken the oil. Thermal stress breaks down hydrocarbon chains, forming color degradation products. Electrical stress can create carbon particles that give the oil a dark, sooty appearance. What makes this test so valuable is its correlation with other parameters. Dark oil usually correlates with high total acid number, low interfacial tension, and high power factor. It's like a visual summary of your transformer's overall health. When you see dark oil, you can predict that other tests will likely show degradation as well. Now here's something crucial that many engineers overlook. Sometimes your visual inspection will contradict your lab results. You might have oil that looks terrible but shows acceptable power factor or breakdown voltage readings. Or conversely, oil that looks decent but shows poor electrical properties. That visual mismatch is a strong warning. Lab instruments analyze samples. Appearance checks the reality. Never dismiss this contradiction. If oil looks bad, something is already wrong, even if your other tests haven't caught up yet. Visual deterioration often precedes measurable changes in electrical properties. This is because the human eye can detect very subtle changes in clarity and color that instruments might miss in their early stages. Let me give you a practical example. You're doing routine maintenance on a 25-year-old transformer. The power factor test shows acceptable values, breakdown voltage is within limits, but when you hold up that oil sample, it's noticeably darker than last year's sample and has a slight haze. Your instruments say everything is fine, but your eyes are telling you a different story. Trust your eyes. Start investigating moisture content. Check for signs of overheating and consider more frequent monitoring. This is why experienced engineers never dismiss appearance as subjective. It is a first-level diagnostic tool that often provides the earliest warning of problems. The key is knowing how to interpret what you're seeing and correlating it with your other test results. When you encounter poor oil appearance or color, here's your action plan. First, correlate with other tests immediately. Check moisture content, power factor, breakdown voltage, and acid number. Look for patterns that confirm what your visual inspection is telling you. Second, investigate the root cause. Is this normal aging, or is there an underlying problem like a cooling system failure or seal degradation? Third, plan your corrective action. This might range from increased monitoring frequency to oil treatment or even complete oil replacement. The beauty of oil appearance and color testing lies in its simplicity and immediacy. You don't need expensive equipment or complex procedures. A clear glass container, good lighting, and trained eyes are all you need for this first-level assessment. Yet, this simple test often tells the truth before numbers do. Remember, your transformer oil is constantly telling you about the conditions inside your equipment. Temperature excursions, moisture ingress, electrical stress, contamination, all of these leave their mark on oil appearance and color. By learning to read these visual cues correctly, you're essentially learning to listen to what your transformer is trying to tell you.
In the world of transformer maintenance, where a single failure can cost millions and affect thousands of customers, never underestimate the power of simply looking at your oil. It's often your first warning, your most reliable indicator, and sometimes your last chance to prevent a catastrophic failure. Trust your eyes, understand what you're seeing, and act accordingly. Your transformers will thank you for it.
So friends, this is the real meaning of oil appearance and color. Clear oil does not guarantee perfect oil, but dirty oil always means a problem. Remember these rules forever. Clear and bright oil, healthy condition, slight darkening, aging started hazy or cloudy oil, moisture or contamination, dark oil or particles, oxidation and sludge risk oil appearance must always be correlated with tan, IFT, moisture, and BDV. If visual inspection looks bad, laboratory results will follow. If this explanation helped you understand why looking at oil matters, then support Electriverse. Like this video, comment below. Have you seen dark oil with normal test values? Subscribe, because next we integrate appearance plus lab tests into one decision logic. You've been watching Electriverse, where every spark tells a story. Stay charged, stay safe, and happy.